Homework 5 then, communication between Cardiff and Paris. So CMP can be achieved by using infrared signal via optical fibre link and using microwave signals via satellite. So there's two ways. So it's showing us there. I know there seems like a lot going on, but try and ignore my writing. And then we'll get to it. So the frequency of infrared waves used in optical fibre is 4 times 10 to the 14. That's all that is, 4 with 14 zeros after it, if I was to write that out. And the wavelength is 5 times 10 to the minus 7. So that's a 0.000005, I think, if I've done that right. So use an equation from page 2 and 3. Calculate the time it takes for the signal to travel. So it's a 4 mark. Whenever you get 4 marks for an equation, it means it probably wants you to use 2 equations. So like I said, in this case, distance, speed, time. We're not given the time because he wants to have a look how long it travels, the time it takes. We are given a distance, which is 4.5 times 10 to the 5. There. Sorry, there. No, where am I getting that from? Yeah, there. That's your distance. But the speed I've not got. But the good thing is I can calculate speed if I know my wavelength and my frequency. And I do. Because it's got... There's the hertz. And there's... Sorry, guys. This is my wavelength. So just to show you where these are in on your front page, it's going to be right down the bottom. So I'm using these two, usually linked together. So you can see my calculations there. I've solved for V. V comes out to be 2 times 10 to the power 8. Then now I've got my speed and I can continue on with time now. My distance, speed, time. Put my finger over T and then it comes out to D over S. And then there comes my answer. Use the equation from page 2 and 3 to find the approximate height of the geosynchronous satellite above the Earth if the time delay between sending out the signal from Cardiff is detected at Paris is 0.24 seconds. So I know my time is 0.42 seconds. And then the speed of the microwaves through space is just standard speed. It's the speed of light, 3 times 10 to the 8. Because all EM waves travel at the same speed. So I think for 3 marks, they've been really generous here for 3 marks. You can actually, I've made hard work of this, but you can actually plug it into your calculator, so long as you know what you're doing with these powers. So I've said there, 0.24 for your time, 3 times 10 to the power 8 for your speed. What's the distance? Well, it's just 1 times the other. And I've done that there, and it comes out to be 7.2 times 10 to the power 7. But we're not done yet, because you probably get 2 marks for that. If I just show you now this diagram, so what's happening, the question's stating really that it's sending so P, or it's either C, is sending a signal up and then it's coming back. And it's calculating the difference in time. You can see that C takes a bit longer there. So it's an approximate height, but you need to half it because it's actually timing the time it goes from there and back down. So if you half that now, you'll get approximate height. And that's what I've done there. I've put 7.2 times 10 to the power 7 over 2. And that gives me the answer, 3.6 times 10 to the power, I think it's 7. I've missed that. Yeah, it seems right then. It's going to be to the power 7. Oh, pardon me. Right. Explain why the satellites must be in geosynchronous orbit. Well, satellites need to be above a fixed point on Earth. That's what geosynchronous, synchronized to Earth, the spin of the Earth. Although you shouldn't think of them as just sort of stationary with the Earth. They are constantly falling around the Earth. It's just that they're falling at the same speed as the Earth is rotating, and that's why they're stationary. It's very, very clever physics. I mean, these people know what they're doing. Your sat-navs, your mobile phone communications all depend on it to within a precision. Even your satellite dish. This is why your satellite dish is constantly pointed in one direction, because it's pointed at the satellite that pretty much is just falling around the Earth at the same speed as the Earth is rotating. I find that incredible. So satellite dishes do not have to be adjusted, and that's your other mark there. Give one advantage of sending signals to Cardiff and Paris by optical fibres. It's going to be much quicker, so you haven't got to wait for that signal. Less time, because it's the speed of light and it's not affected by the weather. So if you get a snow on your satellite dish, you have to get out there and with a brush to clean your satellite dish. That's it is. Nuts. All right, we all have a good 6 mark. There it is. Your 6QWC, your quality of your writing, is being judged here. So I've put it in bullet points because I think once you've got your bullet points done, you just need to tie it up in a tidy argument. And it's just easier to see the marks. But when you get into exam, obviously, you're going to write it as if you were Shakespeare or someone like that. Oh, my cough. All right. In an answer to a recent exam question, a candidate wrote, a single geostationary satellite stays in the same place and is the only way of relaying all electromagnetic waves around the world. Explain in detail what is wrong with this statement. Well, there's a few things wrong, and I've underlined only way, all, and around the world for a reason, and you'll see why. So I've said a geostationary satellite orbits the Earth in 24 hours, the same time as the rotation of the Earth. We've talked about that. It does not stay in the same place. It stays above the same point on Earth, so the dishes do not have to be moved. So it's not as if that satellite's just hovering in the same place. It is actually moving, but it's moving at the same speed as the Earth. A minimum of 3 satellites are needed to send information around the world because the very nature of the world. I don't know if I've drawn a diagram, no. But, yeah, you need at least 3 to get all the way around the world. Not all EM waves are used. Mainly microwaves carry TV, telephone, and other information. And that there. Signals can also be relayed along optical fibres which transfer infrared waves, and then radio waves are also used to transfer information for TV and radio around the world. So it's not just the only way there that they're saying. So that's your 6 marks arguing against this statement, really. Sorry about the cough.